So welcome back, and trig, we are giving it enough justice really. Lesson 7, we are looking at some of the applications of the trig identities. Those identities, we've said, they which are we have cos squared theta plus sine squared theta is equal to 1. We have 1 plus tan squared theta is equal to sec squared theta. We have cot squared theta plus 1 is equal to cosec squared theta. So the applications that I'm talking about, we can use them to solve some trig problems. Ig, number 1, I left a question talking about 2 cos squared theta plus sine theta is equal to what? Now when you look at this question here, for you to go for it, you have to be very keen because we have 2 varying identities in one problem. We need uniformity. How do we create that uniformity? We need to borrow some knowledge from identity 1. So from cos squared theta plus sine squared theta is equal to 1, we have cos squared theta is equal to 1 minus sine squared theta. Someone may ask, why are you changing from, or why are you making cos squared theta the subject, not sine? You look at our question. The one with the highest power is cos. So focus on changing this such that when you are simplifying, you don't have any problems. So if I substitute for cos squared theta in the question, I do have 2 into 1 minus sine squared theta plus sine theta. This one is equal to 1. Now if I open brackets here, this is 2 minus 2 sine squared theta plus sine theta. This one is equal to 1. Okay? So if I simplify this further, this is 2 minus 2 sine squared theta plus sine theta minus 1 is equal to what? To 0. Or I can rearrange it and have 2 sine squared theta, 2 sine squared theta minus sine theta. I'm taking everything the other side. Now here we have a 1. If it goes this side, it becomes a negative 1 is equal to what? Is equal to 0. So what do you have there? We have a quadratic equation. We have a quadratic equation. So since we have a quadratic equation, we can apply the techniques of solving quadratic equations to deal with it. So we have 2, our 2 multiplied by negative 1 to get negative 1. There are 4 factors of negative 2 which add up to negative 1. This is 2 sine squared theta minus 2 sine theta plus sine theta minus 1 is equal to what? What is the common factor here? We have 2 sine theta into sine theta minus 1. Are you following? Okay. Plus 1 into sine theta minus 1 is equal to 0. So we have sine theta minus 1 into 2 sine, it is a sine, 2 into sine theta plus 1 is equal to 0. So either sine theta is equal to 1 and theta is the sine arc of 1, that is a positive ratio. So we are talking sine arc of 1 giving us 90, and we are not going to add on anything on this 90 because even when you move to the next angle you'll get the same thing. Or we have 2 sine theta plus 1 is equal to 0, meaning sine theta is negative what? So theta is the sine arc of negative half. Theta is the sine arc of negative half. Sine theta is negative in, or sine is negative in the third and fourth quadrant. It is negative in the third and fourth quadrant. So if I draw that, if I consider this positive, I'll get theta as 30, but it's not the one I want. So I'll pick the angles in the third and fourth quadrant. So in the third and fourth quadrant, I have 180 plus theta, which is 210 degrees, and 360 minus theta, which is 330 degrees, which is 330 degrees. So therefore, theta is equal to 90 degrees, 210 degrees, and 330 degrees, and 330 degrees. I'm going to look at one more question about this. I'm going to look at one more about that, such that at least I don't leave anybody behind. Why am I picking one of that is, you may find something like 4, this was our Roman 3, 4 cot squared theta plus 39 is equal to 24 cosec theta. So from yes, cot squared theta plus 1, this is equal to cosec squared theta. So you make a cot the subject. Cot squared theta is cosec squared theta minus 1. So we have 4, I'm substituting up there, 4 into cosec squared theta minus 1 plus 39 is equal to 24 cosec theta. If I open brackets here, this is 4 cosec squared theta minus 4 plus 39 is equal to 24 cosec theta. Are we together, ladies and gentlemen? Okay. So this is 4 cosec squared theta plus 35 is equal to 24 cosec theta. So you bring this side, you have 4 cosec squared theta minus 24 cosec theta plus 35 is equal to what? 0. We have quite big values. So if they are big, this is a quadratic but in trigonometric form. So since they are big values, you can apply the quadratic formula from, I can say cosec theta is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. Okay? Very good. So our cosec theta is going to be negative of negative 24 plus or minus the square root of negative 24 squared minus 4 into our a is 4 and our b, so our c is 35 all over 2 times 4. So all over 2 times 4 all over 2 times 4, we have our cosec theta as, this is now 24 positive, plus or minus the square root of, I think, 576. You have negative 24 squared is 576 minus, that is 16 times 35. This is 560, okay, over 80, not 6. So this is 24 plus or minus the square root of 16 over 80, which is 24 plus or minus 4 over 80. This is cosec theta. So either cosec theta is, when you add, if you consider the positive part, you'll get 28 over 8, or I think by 4, 7 by 4, 2. That is cosec. Or cosec theta, if you take the negative part, you get 24 minus 4, which is 4 over 80. So by 4, 5 by 4, 2. Now, this is cosec, not. I think why I chose it. So cosec is 1 over sine theta. Okay? Reciprocal. So if you want to use a sine, when cosec theta is equal to 7 over 2, that means sine theta is the reciprocal. So it will be 2 over 7. Are you seeing the magic? So we have theta is the sine arc of 2 over 7. Get the calculator. That is a positive ratio. Angles should be from 2 quadrants, 1 and 2 together. Thank you. So we have shift the sine arc of 2 over 7, close the bracket C. So we have theta as 16.60 degrees. Now to get the other angle, it is 180 minus that. You'll have 163.40. Okay, and when cosec theta is 5 over 2, sine theta is 2 over what? 2 over 5. So our theta will be the sine arc of, or arc sine of 2 over 5. Therefore, I'll get my calculator and have 2 divided by 5, giving me, this is 23.58 degrees, then minus 180, you have 156.42. Those are all degrees. Then you can rewrite them in the order that you want. So ladies and gentlemen, we are looking at these identities, and we have looked at how to deal with them in solving. How can you apply these identities when you're solving a certain quadratic equation? How can you deal with it to solve quadratics? Okay? Now, how about if you're told to prove, for example, what if you are told to prove the identities below? Identities below. Part A can have cosec. Let's start with this one. Cosec theta plus tan theta sec theta. This one is equal to cosec theta sec squared theta. Sec squared theta. The question is, we are proving, okay? We are proving the identities. Now, when they talk of the word prove, you can start from any side of your choice, okay? You can start from the left hand side, you can start from the right hand side. So if I consider the left hand side, we have cosec theta plus tan theta sec theta, which is, this one is, I can put it as 1 over sine, okay? Then plus, can put this as sine theta over cos theta, then times 1 over cos theta. Are we together? Which is 1 over sine theta plus sine theta over cos squared what? Theta. So LCM, the LCM is sine theta cos squared theta. Okay? So sine theta goes here, cos squared theta times. So we have cos squared theta plus cos squared theta goes here, cos squared theta goes here, sine theta. So sine theta times this other sine theta, you'll get sine squared theta. Now, when you look at cos squared theta plus sine squared theta, cos squared theta plus sine squared theta, you get a 1 over sine theta cos squared theta. Or I can put it as 1 over sine theta times 1 over cos squared theta. Now this one is cosec, 1 over sine theta is cosec theta. Then cos is sec squared theta. Ladies and gentlemen, you have been nice learners. Please tell a friend to subscribe to QuestLift so that you can become genius in this. Thanks for watching.